I do want to just have a little bit of a kind of personal journey of why I got into online experiments, because I think that frames where I've got to in terms of how I think about data quality online. I'm going to try and I'm not going to offer lots of specific solutions, because my main point is there are no general solutions, there are lots of specific solutions, and if I'm going to was to sit here and list all the specific solutions, nobody would get any lunch. So what I'm going to try and do is present a more general framework of the types of things you need to consider and the types of solutions that work. And what I'm hoping is then the more specific talks that we get this afternoon, some of what they have done in their studies will kind of slot into this framework, and you'll get an idea of what's possible. So I'm going to offer a kind of framework. So I'm not going to talk about recruitment, because we've just heard lots about recruitment. That's really, really, really important to maintaining data quality. And if I know I'm not going to talk about it, but the one thing I'm going to say is pay them properly. If you don't pay your participants properly, you don't get good data. I'm not going to talk about the tech stuff, because that's kind of been dealt with this morning. So, and I'm not going to talk about all the ethics to do with non-payment of participants. So I'm going to talk a lot about excluding participants from your study, but I'm talking about excluding their data from your analysis. I'm not talking about excluding them from being paid. It's really important to separate those two things. Is this participant, have they met the requirements for me to pay them, is completely separate to have they met their requirements for me to analyse their data. So I'm not talking about payment. So I don't want to talk about my research, but just to give you the background, the studies we've been doing are looking at language processing, in particular language learning, how you're constantly learning new meanings. So you had a word trunk, and then you read a Harry Potter book, and then you realise it can refer to a suitcase. Learning those new meanings and then fine-tuning and tweaking them throughout your adult life so that you maintain appropriate representations. I got into online experiments because there were some really cool things I wanted to do that you simply could not do in the lab. The first study we did was this really fun, exciting collaboration with Radio 4, which was wonderful because we basically got to present the stimuli on the radio, which isn't something you can do in the lab. You know, you need people are online, have their radio on, they're listening to your stimuli effectively. And then the only way of then testing them is to do some kind of online web-based task. The details of the task don't matter. What mattered was, at the time, so we published it in 2016. I'm a very slow writer, so we probably collected the data a couple of years earlier. At the time, the idea of getting 2,500 participants just blew my mind. But to be honest, I didn't really think about data quality very much. I was running an experiment that I could only run because I was doing it online. And as far as I was concerned, noisy data was a price I was just going to have to pay for the fact that I was running it this way. And I didn't think very much about how I would deal with quality of data. It's just lots of it. Yeah, let's get more data. Similarly, we started running some experiments which we could only run online because we wanted to recruit from particular participant groups. So we ran what I call the rowing experiment, where we basically recruited lots of recreational rowers because they have very specific use of vocabulary that we could do lots of cool things with. And again, that is something you could not do online. You could not do in the lab because we wanted to recruit from this very diverse rowing population. Again, it was just lots of cool data, you know, this is really exciting, but I didn't think very much about the quality of that data. Where quality became a real issue for me in my lab was when we started to run experiments that we could have run in the lab, that we were running online because the data collection was efficient and because we could collect more participants and be better powered, but actually there was no scientific reason that we couldn't do it in the lab. And that gets you to a point where you really have to start justifying your choices, and you know your reviewers are going to give you a hard time if they don't trust their data. Just to give you a little kind of a glimpse of why we've made the switch. So for my lab, our default now is we run it online unless there's a good reason not. This is the front page of my student Hannah's thesis, which has just been submitted. And I just want you to look at the bottom there. Half of the experiments in her thesis were online. Her thesis has 900 participants. And these are not these are proper experiments. These are the kinds of boring psycholinguistic stuff that we do day in, day out in the lab, transferred online. And there is no way I could get a PhD student and say to them, you need to run 900 participants for an hour-long experiment in the lab. It's just not possible. So what have I learned along my journey of data quality? Firstly, it is much, much better than we feared. I was told, rule of thumb, you need twice as many participants online as you need in the lab. It varies massively experiment to experiment, and we can talk about that later if you want. But that 2-to-1 ratio, in my experience, is not even close to being true. If you design your experiment right, we're getting comparable data quality. You get more variance because you're recruiting from a wider participant pool. The language, in my case, we're doing language stuff, so the range of language skills is much wider. So your error bars are bigger, but that's not data quality. That's your participants being different. The other thing I've learned is that the things that I really worry about when designing an experiment online are specific to that particular experiment. There aren't any grand solutions that I can offer you and say, here's a tick list. If you do all of this, your experiment will work. You've got to it's experimental design 101. It's what we teach our undergraduates. You've got to think about your particular experiment and the ways in which it can go wrong. And the good news is, you come up with these concerns, and in most cases there's a fix. And if you can't come up with a fix, somebody else probably has done already. So I'm going to kind of talk you through a kind of 5-stage process that I would recommend for any experiment that you're going to run online. And the important thing, this is all stuff you do before you get any data. In the ideal, this is kind of do what I say, not what I do. Right. The first thing is to think about your specific experiment. What are you worried about? And in general, people's concerns, and I've done lots of kind of Twitter surveys and stuff, in general, people are worried about 3 things. They're worried that participants are lying and they are not who they say they are. And that concern is different for different experiments. So I might be worried that they're lying about their language background. They think if I say I'm English first language, I will get to do more studies. Other groups, for example, Hugo, I know, has had problems where people have been lying about their age because they want to do his thing, and he has said you have to be 18, so everybody's saying they're 18. So amazingly, he has more 18-year-olds than any other demographic. But depending on the constraints of your particular study and the way you've set your reward structure up, people are going to lie in very specific ways. But you need to think about, do I care? So I don't care if somebody's actually 24 and not 25, but I really care if their language background is not what they say it is. The second concern is that participants cheat, like deliberate, I'm going to not follow your instructions and I'm going to do something naughty that breaks the rules of your experiment. Now, most of the experiments that I ever run, you can't cheat. There is no way of cheating speeded semantic relatedness tasks. Well, I don't know. I mean, maybe if you had... I don't even want to think about it. But there are tasks where you clearly can cheat. If you're throwing out a vocabulary test, people can look stuff up online. And particularly if they think you're going to throw them off your experiment for not being native English, there's an incentive to possibly cheat. If you're doing working memory tasks, can they be writing down the things they're supposed to remember? But again, these are experiment specific. Is there a way that somebody could cheat for your specific experiment? Probably the thing that we've given most of our time thinking about is the attention issue, that people are not attending. And obviously this is not just online experiments. Newsflash, people in the lab don't always attend either. And people in the lab don't always have an experimenter sitting behind them. It's fairly routine to get 5 participants in, send them to 5 cubicles and let them get on with it. But we need to think about, what are we worried about? Are we worried that they didn't attend to the instructions, so they're doing a slightly different task to what I thought they were? Am I worried that they're hitting random buttons? Am I worried that they're multitasking and they're texting their friend or looking at cat pictures online? What exactly is it that I'm worried about? So that's the first thing. Think about what you're worried about. And the rewards here are important. I've touched on this before. Why would they lie? Why would they cheat? You need to kind of get yourself into the mindset of the participant. Is there something in the payment structure or the in-game app? I'm going to give you lots of prizes for getting 10 out of 10. Is that going to incentivize cheating? You need to think about the reward structures that you've set out. You've specified your concerns. Then you think about the worst case scenarios. How could these concerns destroy your experiment? If they're not who they say they are. If I'm doing an experiment, monolinguals versus bilinguals, and actually they're the same people, I'm not going to get meaningful data. If participants cheat, well, my data may be unusable, or it may be unpublishable. And remember, those are 2 different things. And I'm going to come back to this later, but there's this issue of data. Can I persuade myself that my data quality is fine? But I also need to persuade the reviewers and the readers of my paper that my data quality is fine. So you need to build in safeguards so that annoying skeptical reviewer who thinks no experiments should be ever done online get some kind of sense of security that you know what you're doing. So what would be the worst thing that would happen if people aren't paying attention? Are they just going to add noise to your data, which is no big deal, or are they going to systematically screw up your results in ways that are going to make your theoretical conclusions invalid? So you've identified your concerns, you've thought through what's the worst that can happen. Then you design your exclusion criteria. You think in advance, what reasons am I going to use for throwing somebody out of my study? And there's all kinds of things you can do. You know, if you're worried about language skills, you can do your vocabulary test speeded. I would do, by the way, I do everything speeded. Every online experiment, I would get timing information for everything you do. For me, that's the most helpful thing for excluding rogue subjects. If there were really important demographic questions, ask them at the beginning and the end. Ask them in different ways. Build in those safeguards. Cheating. Again, the reaction times can be really helpful to pull apart the people who are cheating, and you may be able to specify some predictable patterns in the data. So if you're doing a short-term working memory, you might be able to say, okay, we know a priori people are going to be better at 5 items than 9 items. If I have any subjects who are better at 9 items than 5 items, I'm going to exclude them. So you need to think about the details of your experiment. What could you use as a marker of cheating? And there are some tasks where that's just not possible. You're never going to persuade reviewer 2 that your participants haven't cheated. The attention thing, there are so many things you can do. You can specify exclusion criteria in terms of people being slow or variable. You can exclude people who took 2 seconds to read your instruction page. You can exclude people who took a 30-minute gap between blocks in your experiment. You can add catch trials. You can do cool entropy measures to catch the people who are pressing the same button lots and lots of times. You can ask the same question twice. You can ask questions about the instructions at the end of the experiment to make sure that they actually understood what they were supposed to be doing. You can look at the total duration. These are all things that you can specify in advance that if somebody doesn't meet these criteria, we don't trust their data. Then, this is the point we've just heard from Katia, you pilot and you pilot and you pilot again, particularly if this is a new task or a new population. Because this is how you know that your exclusion criteria are going to work. You know that that these are that what you're expecting a typical participant to do will not be excluded. Ideally, you run some participants in the lab where you can actually see what they're doing, you look at their data, and you see how their actual behaviour maps onto your exclusion criteria. You need to make sure that your exclusion criteria are sufficient, that they are getting rid of all the people whose data you would actually really like to get rid of because you don't trust it. And you need to make sure they're appropriate, that you haven't been overly harsh, that for example, that your language screening isn't causing you to throw out participants who really should be part of your sample, that you're not screening out the tail of the real distribution. And then this is my big kind of, please do this, you pre-register your exclusion criteria. I'm a big fan of pre-registration, so stating in advance things about your experimental method, but I think for online experiments and exclusion criteria, it's particularly important. On the one hand, web-based experiments give you high-quality data, but it is still the case that compared with a lab-based experiment, you will have more exclusion criteria. There will be more reasons for throwing people out, for excluding them from your analysis. And you will have more participants that you will decide don't meet your criteria. You will have more people who just get bored and don't do what they're supposed to, or who have clearly lied about their background. So you will be excluding more people, and you will be using more reasons for excluding people, in my experience. And pre-registration is really important then, because, again, we're thinking about the skeptical reader. They read your paper, and you tell them, I excluded people for these 6 reasons. That skeptical reviewer is going to think, well, is this good science? Is this good data quality management? Or is this cherry picking? Has this person collected 100 participants and then decided, oh, look, if I throw out these people, it looks better, and if I throw out these people, it looks better? So by pre-registering your exclusion criteria, you're protecting yourself from the accusation that you've used those exclusion criteria to cherry pick your data. Pre-registration, in my view, will improve the quality of your experiment because it will force you to think about this up front. It'll force you to think, have I got good mechanisms for checking that people are paying attention and checking people are not cheating? And as I've said, it gives reviewers and readers trust in your results. We register on Open Science Framework. Obviously, there are other ways to do it. So, You specify your concerns, you think about the worst case scenario, you decide on some sensible exclusion criteria, you pilot to check that those are sensible, and then you pre-register. And of course, you then have the perfect experiment. And then the data arrives. And every experiment, every new task, you will find new and exciting forms of weirdness. People are incredibly inventive. In the lab and in online experiment, they will find new ways of screwing up your experiment. The most common thing is you'll get, we always have an open-ended question at the end where they get to tell us anything they want. And they will say, yeah, I really enjoyed this. I was doing it in the pub with all my friends and we were deciding the answers between us. And you're like, great, thank you. So you need to review things once the data is in. The key point is that you've pre-registered, to your best of your ability, you've said what you're going to do in advance, but it's okay to deviate from that pre-registration. But transparency is key. If you're going to do something different, you report in your paper. I followed my pre-registration, except that this person who said they were drunk, I decided to take them out. People have mixed views on this. I like to check the data quality as it's coming in. Now, you have to be very careful here that you're not testing your analyses, nothing to do with predictions. I'm not looking at differences between conditions. I'm not p-hacking. I'm just looking at data quality because, frankly, if it's all going badly wrong, I want to intervene before I've spent hundreds of pounds. Debriefing at the end is important. These kind of did you cheat questions. Some people like to use those as exclusion criteria. I'm not a fan of that. But I'm a fan of asking people if they've cheated at the end as a way of fine-tuning your exclusion criteria. If somebody cheated on a working memory task, what is there in the data, in their data, that could have allowed you to figure that out in advance? And obviously, this debriefing is helpful for doing things better next time. We're continuously refining exclusion criteria. Some reflections. This is stuff we should be doing all the time. Nothing's different. Collecting data in the lab and in the wild is not actually that different. I think we have this naive overconfidence in what goes on in the lab. Normally we're not looking over their shoulder. We're not checking that they're not on their phone looking at cats. We should be doing this for our lab experiments as well. And just to reiterate this point, that you're not just trying to persuade yourself that your data is good, you're also looking for objective evidence that will persuade your readers, your reviewers, your peers, and so on, that your data is good. Some references I've just put up there in no particular order, and that is what I have to say, just to thank all the really fabulous people in my group. A lot of this has been led by them. What I've tried to do is to pull together a lot of ideas that they have collaboratively come up with over the last 5 years. Thank you.